Every time you look up at the night sky, you are looking into the past. The light hitting your eyes right now left its source years, centuries, sometimes billions of years ago. You are not seeing the universe as it is. You are seeing the universe as it was. For most of human history, that was the limit. We could look back, but never far enough, never clearly enough to see how it all began. Then, on Christmas Day 2021, we launched something that changed the rules. The James Webb Space Telescope wasn't built to take pretty pictures. It was built to answer one impossible question. What did the universe look like before there was anyone around to see it? And in the last few months alone, Webb has come back with answers that are making astronomers rewrite their textbooks. Not once, but 4 separate times. A galaxy that shouldn't exist. A black hole older than its own home. Weather forecasts from worlds hundreds of light years away, and a map of the invisible scaffolding that holds the entire universe together. This is what Webb found, and why none of it quite adds up yet. Start here, because this one broke a rule astronomers thought was unbreakable. In May 2026, a team led by researchers at UC Davis pointed Webb at a galaxy called XMM-VID1-2075. Nothing unusual about the name. Everything unusual about what they found. This galaxy formed less than 2 billion years after the Big Bang. In cosmic terms, that's early, practically newborn. Young galaxies, according to every model we have, should still be chaotic, swirling, spinning, violently assembling themselves out of gas and collisions, and spinning it all. Instead, its stars move in random, disordered directions. The signature we normally associate with galaxies that are old, evolved, settled. The kind of galaxy you'd expect to find nearby, not one that existed when the universe was a fraction of its current age. One of the researchers put it simply, it's a bit surprising to find this so early on. That's scientist speak for this shouldn't be here yet. So how did a galaxy skip millions of years of turbulent adolescence and go straight to old age? Nobody knows. But it's not the only thing Webb found that seems to have shown up too early. Here's a stranger one. Deep in a galaxy called Abell 2744-QS01, more than 13 billion light-years away, Webb's instruments mapped the motion and composition of gas swirling around a supermassive black hole. The black hole weighs about 50 million times the mass of our sun. That alone isn't shocking. What's shocking is the timeline. The data suggests this black hole predates its own host galaxy, not grew alongside it, not formed from its collapsing core, came first. Some researchers now think it may have formed within the very first second after the Big Bang, already massive, already there, before the galaxy around it had even begun to take shape. Every model of galaxy formation assumes the galaxy comes first, and gravity slowly builds a black hole at its center over time. This observation flips that order. It suggests some black holes weren't born from galaxies at all. Galaxies may have formed around them. We are quite literally looking at the chicken and egg problem of the cosmos. And Webb just told us we might have the order backwards. Now zoom in. Close, personal, almost mundane, and that's what makes it remarkable. 600 light-years away sits a gas giant called WASP 94AB. In late May, astronomers using Webb discovered something we've never directly observed before: a daily weather cycle on an alien world. Every morning, mineral clouds, real clouds made of vaporized rock, form across its sky. By evening, they vanish, leaving the atmosphere clear. Morning clouds, clear nights. A forecast for a planet that isn't even in our solar system. One of the study's co-authors has spent 20 years fighting a specific problem. Clouds on these worlds are usually a nuisance, a haze that blocks the view, like trying to look through a foggy window. Webb didn't just see past the fog this time. It watched the fog form and disappear in real time across a single planetary day. And it's not alone. Around the same time, Webb studied a different planet, TOI 199b, a world the size of Saturn, but with temperatures far closer to Earth's than anything else we've found at that size. Its atmosphere is rich in methane. It's one of the first temperate gas giants we've ever been able to study in real detail. Put those two together, and something is shifting. We are no longer just detecting exoplanets. We are starting to describe their climates, their mornings, their seasons, their air. Worlds that were single dots of light a decade ago now have weather. Every so often, Webb pushes its own record. In 2026, it did it again. Astronomers confirmed a bright galaxy that existed just 280 million years after the Big Bang, the earliest, most distant confirmed galaxy we have ever detected. 280 million years sounds like a long time, until you remember the universe is roughly 13.8 billion years old. In percentage terms, we are looking at the universe when it was less than 2% of its current age. And it isn't isolated evidence. This year, a separate team used Webb to build one of the most detailed maps ever made of dark matter, the invisible material that makes up most of the mass in the universe. The new map contains 10 times more galaxies than earlier ground-based surveys, and twice as many as Hubble ever managed. It reveals the cosmic web in far sharper detail than before. Dense knots of dark matter connected by faint filaments with ordinary matter, stars, galaxies, us, tracing the same hidden structure like frost forming along wires we can't see. For the first time, we're not just glimpsing the earliest galaxies. We're starting to see the invisible framework they grew on. Not everything Webb finds gets explained. Some discoveries just get sharper. Since 2022, Webb has been finding strange, compact, intensely red objects scattered across the early universe. Astronomers call them little red dots, and for years nobody agreed on what they actually were. Failed stars, dust-choked galaxies, something else entirely? In 2026, the spectrum of one particular little red dot gave researchers their clearest piece of the puzzle yet, evidence connecting them to the rapid, chaotic growth of early supermassive black holes. The picture isn't complete, but for the first time the pieces are starting to fit together into something coherent, rather than a scattered handful of oddities with no shared explanation. That's often how it goes with Webb. It doesn't hand us finished answers, it hands us better questions. So what does all of this actually mean? Step back and a pattern emerges across every one of these findings. A galaxy that grew up too fast, a black hole that arrived before its home was built, clouds that behave like clockwork on a world we'll never visit, a galaxy so far away its light left before atoms had even finished cooling into stars, and a dark, invisible web underneath it all, finally coming into focus. None of these are separate stories. They're fragments of the same one, the story of how a universe with no shape, no light, and no structure became the one we live in, full of galaxies, black holes, and at least one planet asking questions about it. Webb was designed to look back roughly 13.5 billion years to the first glimmers of light after the Big Bang. It has more than 20 years of operational life still ahead of it. If this is what it found in a single year of observations, it's worth sitting with a genuinely uncomfortable thought. We may still be closer to the beginning of Webb's discoveries than the end. The universe kept its earliest secrets hidden for over 13 billion years. It's only been giving them up for 4. What do you think Webb finds next?